Aston Martin is taking a radically rebuilt version of its 2026 car to Hungary, and the changes go far deeper than a new wing or a different floor edge. Adrian Newey has ordered weight removed from the chassis and gearbox, a new nose has been created, major aerodynamic surfaces have been redesigned, and part of the car has gone through crash testing all over again. Some people are already claiming this package could unlock 2.5 seconds of performance. But that number has not been confirmed. And the real story is far more important than one dramatic lap time prediction, because Hungary may reveal whether Newey has finally corrected Aston Martin's deepest design problems, or whether the entire 2026 project was compromised before the car ever reached a racetrack. Subscribe to the channel. To understand why this upgrade matters so much, forget the exciting headlines for a moment. Look at where Aston Martin actually stands. The team entered the new Formula One era with almost every ingredient people believed a future champion needed. A modern factory. A works partnership with Honda. Fernando Alonso in the cockpit. Adrian Newey leading the technical project. Huge expectations. Serious investment. On paper, it looked like the beginning of something historic. On the track, it became a disaster. Aston Martin arrived at the Belgian Grand Prix sitting at the bottom of the Constructors' Championship. The team had scored only 1 point during the entire season, earned by Alonso in Monaco. Reliability problems had repeatedly interrupted races, and the car had rarely looked capable of fighting anywhere near the front. Belgium made the situation even harder to ignore. Alonso finished 19th, 2 laps behind. Lance Stroll retired after 25 laps because of another problem with the car. That result was not simply one difficult weekend. It was the latest sign that Aston Martin's original 2026 concept had failed to deliver what the team expected. And this is where the Hungarian package becomes different from a normal upgrade. Most Formula One upgrades are evolutionary. A team may adjust the shape of a floor, change a front wing flap, modify a cooling outlet, introduce a different beam wing. Each individual part may look important, but the fundamental car remains the same underneath. Aston Martin is doing something much more serious. Newey confirmed that the main chassis and gearbox architecture will remain, but weight has been taken out of both structures. That work was significant enough for the front section of the chassis to require fresh homologation and another crash test. Think about what that means. A Formula One team does not casually reopen the structural heart of a car during the season. It costs time, resources, manufacturing capacity, and development attention. It also creates risk, because every structural change has to remain safe while becoming lighter. Aston Martin decided that risk was necessary. That tells us the original problem was not cosmetic. It was built into the car. Newey has admitted the 2026 Aston Martin is a long way overweight. Part of that problem came from vibration and integration difficulties involving the new Honda power unit. Another part came from Aston Martin not having enough development time to optimize every component properly. Newey explained the problem in brutally simple terms. When a car is designed in a rush, weight is one of the first things to suffer. Imagine packing a suitcase 5 minutes before leaving for the airport. You do not carefully choose the lightest combination of clothes. You throw everything inside, force the case shut, and hope it survives the journey. That appears to be what happened, in engineering terms, with Aston Martin's original car. It was completed under pressure. Parts were made strong enough to function, but not always light enough to perform. Solutions were added quickly. Integration problems created further compromises. And every extra kilogram made the car slower. But weight alone does not explain the scale of Aston Martin's collapse. This is where the story takes a more uncomfortable turn. Newey revealed that serious work on the 2026 car did not begin until the middle of March in 2025. The first wind tunnel model did not arrive until the middle of April. By then, several rival teams had already been developing their cars for months. Under stable regulations, a delayed start can sometimes be recovered. Teams understand the established design language. They know which concepts work. They can study existing cars and refine familiar ideas. The 2026 rules changed almost everything. The cars became smaller and lighter. Active aerodynamic systems became central to performance. The power units changed. Energy management became more important. The relationship between drag, downforce, electrical deployment, and straight-line speed became more complicated. Starting late under those conditions was like joining a complicated race after everyone else had already completed the opening laps. Aston Martin was not merely behind on manufacturing. It was behind on understanding. And that difference matters, because a team can build new parts quickly. It cannot instantly replace months of learning. The wind tunnel is where engineers test how air moves around a model of the car. Tiny changes can reveal whether airflow remains attached, whether the floor produces stable downforce, or whether the front of the car sends disturbed air toward the rear. But wind tunnel time is limited. You cannot simply run the tunnel every hour until the problem disappears. Formula One restricts aerodynamic testing, and teams have to decide which ideas deserve each run. A late start means every experiment becomes more valuable, and every wrong direction becomes more expensive. Aston Martin's first car therefore had to be designed before the technical group had fully explored the new regulations. That helps explain why the car looked bold but performed poorly. During testing, observers noticed unusual details around the nose, front wing, side pods, and floor. The car appeared aggressive. The shapes suggested Newey and his team were chasing powerful aerodynamic behavior. But dramatic bodywork means nothing if the entire platform cannot support it. Imagine wearing the fastest running shoes in the world while carrying an overloaded backpack. The shoes may be technically excellent. The backpack still slows you down. That is the challenge Aston Martin has faced. The aerodynamic ideas may contain potential, but the weight, vibration, structural compromises, and power unit integration problems have prevented the car from using that potential consistently. Now Newey is attempting to remove the backpack. But there is another reason Hungary matters. The package includes a completely new nose and substantially revised aerodynamic surfaces. The rear suspension has also been modified slightly, while the front suspension remains unchanged. Those details reveal where Aston Martin believes it can make progress without replacing the entire car. The nose controls more than the air directly in front of the driver. Its shape influences how airflow reaches the front wing, travels around the front tires, and continues toward the floor. If that flow becomes messy, every part behind it has to work with disturbed air. It is like opening the wrong door in a crowded building. People begin moving into the same narrow space. The hallway becomes blocked. Every room behind that entrance becomes harder to reach. A new nose can change the path of the airflow before the problem spreads. But the nose cannot work alone. That is why the revised aerodynamic surfaces are so important. Aston Martin is not replacing one isolated component. It is trying to create a new relationship between the front of the car, the central bodywork, the floor, and the rear. This is the first clue that the Hungarian car may be closer to the machine Newey originally wanted to build. Not a completely new chassis. Not an entirely different gearbox. But a major correction based on lessons the team did not possess when development began. That is why people are calling it a second specification car. The original version was built while Aston Martin was racing against the calendar. The Hungarian version has been developed after months of painful evidence. Every failure has produced information. Every slow corner has exposed weakness. Every vibration has identified stress. Every difficult race has shown where the theoretical design and the real car separated. The season has been humiliating. But it has also been one long test session. And that changes the meaning of the upgrade. This is not only an attempt to score more points. It is an attempt to prove that Aston Martin now understands its own car. That distinction could decide much more than the Hungarian Grand Prix. Fernando Alonso's future may be connected to what happens next. Newey has said Alonso wants to see clear and tangible progress. He is excited about the upgrade, but excitement is not enough for a driver who has spent years waiting for another competitive car. Alonso does not need a promise. He needs evidence. A sharper qualifying performance would be evidence. Better tire behavior would be evidence. Fewer reliability problems would be evidence. A car that responds logically to setup changes would be evidence. Even if Aston Martin does not suddenly fight for victory, the direction of travel matters. Drivers can accept a slow car when they believe the problems are understood. What becomes difficult to accept is a car that remains unpredictable. An unpredictable car destroys confidence. A driver turns into a corner without knowing whether the rear will remain stable. The engineers change the setup without knowing whether the improvement will appear. The strategists plan a race without knowing whether tire wear will follow the expected pattern. Every department begins making decisions with incomplete trust. That is how one technical weakness spreads through an entire team. And it may explain why Aston Martin's season has looked worse than the raw pace alone. 10 retirements across the campaign are not simply lost results. They remove track time. They prevent comparison. They interrupt development. When a car finishes a race, engineers receive a complete picture. They see how temperatures changed, how tires aged, how energy was deployed, and how components behaved over a full distance. When the car stops early, that picture remains unfinished. Aston Martin has been trying to catch its rivals while repeatedly losing the information needed to catch them. This is also why the Honda relationship deserves attention. A works engine partnership should eventually provide a major advantage. The chassis team and power unit manufacturer can design around each other rather than adapting separate products at the last moment. But that level of integration takes time. The new Honda system created vibration challenges that affected the car's structure and weight. Solving those problems required Aston Martin to strengthen or modify components. Stronger parts can become heavier. Heavier parts hurt performance. Performance pressure then forces engineers to search for weight savings elsewhere. One problem creates another. Then that second problem changes the aerodynamics. Then the aerodynamic compromise affects tire behavior. Then the tire behavior changes strategy. This is how a Formula One project can unravel without one single catastrophic mistake. There may be no villain. There may be a chain. A late start leads to rushed design work. Rushed work creates excess weight. New power unit integration creates vibration. Vibration demands structural solutions. Structural solutions add further weight. The aerodynamic concept loses efficiency. Limited track running slows the learning process. Reliability failures remove more data. By the time the team reaches the first races, every department appears to have a separate problem. In reality, the problems may all come from the same beginning. That is the deeper question Hungary will answer. Has Aston Martin finally broken the chain? The new nose will attract photographs. The revised surfaces will attract technical analysis. The lighter structure will generate dramatic headlines. But the most important change may be less visible. Aston Martin has had time to redesign the car with real evidence. Not computer predictions alone. Not wind tunnel expectations alone. Real evidence from a season in which the original design repeatedly failed.